All right, gang, it is lesson 51, scientific notation for large numbers. I am going to admit that it is late. I did not realize I had to have this done by tomorrow. We had class today, and so I'm just telling you, this might not be the most exciting, best video I've ever done. So I apologize for that. I will do my best. Go ahead, though, and start out with the warm-up. I'm going to try the warm-up, and we'll see how fuzzy my brain is. Maybe you'll find a mistake. This would be a good one to find a mistake in. And I will see you once we get those done. All right, here's our warm-up. 4 times 350. There's two ways to do this. You can do 4 times 3, which is 12, and then 4 times 50, which, or 50 cents would be $2, so 12 plus $2. Or you could, sometimes I think about 350, 2 350s is $7. So we've got 4 of them, so we've got 2 sets of $7, so we've got $14. Two ways to think of that. Okay, this one where decimal just moves 2 places to the right, so 1, 2, 450. This one I do 20 times 3, which is 60. 60 divided by 5 is 12. This one, 5 kilometers to meters. Well, there are 1,000 meters in 1 kilometer, so there are 5,000 meters there. Okay, 15 squared. I want you to get to the point where you remember that's 225. Minus 25 is 200. All right, 45 divided by 9 is 5, times 5 is 25. So there we go with the warm-up. Give yourself a pat on the back if you got that one. And now we're going to talk about scientific notation for large numbers. The numbers used in scientific measurement are often very large or really small. And they usually take up too much space on a calculator. So we jump into this thing called scientific notation. It's a way of expressing numbers as a product of a decimal number and a power of 10. In scientific notation, a light year is 9.461 times 10 to the 12th kilometers. Okay, pretty far. In the table below, we're going to look at scientific notation to look at kind of some things that might be relative to you. All right, the width of a pencil, right? So this is a mechanical pencil, but they say it's about 2 millimeters. Mine is bigger than that. And how we do that in scientific notation would be 2 times 10 to the 0 power. Because remember, to the 0 power just means 1, so it's about 2 times 1 millimeters. Diameter of a quarter, so we're getting a little bigger, is about 24 millimeters. And the way you would write that would be 2.4 times 10 to the first power millimeters. Now notice when we have scientific notation, all of these have 1 digit in the ones place. You can't have more than that. It has to be 1 digit in the ones place, and everybody else is going to be in the decimal world. Okay, so meaning like 1.6. So instead of saying 160, you're going to say 1.6. Instead of 4,500, it's going to be 4.5 times 10 to a power of, or 10 to a power of 3. 2.9, 1.1, 1.6, and 4.2. So there's always, this last number here goes in the ones spot. And then the rest are how many places does that decimal move. Okay, so look at the patterns here, and really look at, you know, how the distance of a marathon is about 42 million millimeters. Okay, how would you write 42 million millimeters? You could write it 4.2 times 10 to the 7. So they're showing you that we can write it more simple. Okay, again, not my best work here. My voice is disappearing, and I am not firing on all cylinders. It's a little late tonight, so I apologize. Write 2.46 times 10 to the 8th in standard form. So they gave us scientific notation, and we got to figure out what it looks like over here. Two ways to do that. 10 times, or 10 to the 8th power. That's the same as saying 2.46 times 10 to the 8th power would be 1 with 8 zeros. So I got 1, 2, 3, 4, 5, 6, 7, 8. All right, so that looks like 100 million. 2.46 times 100 million. Again, we're still not sure what that means. Well, this is a magic number. This decimal point is going to move 8 times. So we're going to have to, there's 2 times, 3, 4, 5, 6, 7, 8. And there is our answer. So the decimal was here, and it moved to the right 8 times. 1, 2, 3, 4, 5, 6, 7, 8. So it's 246 million is the standard form of that. Okay, let's look at the next example. Write 40,720,000 in scientific notation. So again, the first number there is going to be in front of the decimal. That means the rest, we're going to say 072 until we get into placeholders. Okay, so we're going to have 4.072 times 10 to a certain power. Now, what power does it move? Okay, so it was here, and now it's here. So how many spots did it move? It went 1, 2, 3, 4, 5, 6, 7 places. It moved 7 places, and so we get 10 to the 7th. Okay. All right, now we're going to compare these two numbers. 1.2 times 10 to the 4th, or 2.1 times 10 cubed. Now it would be good to just put them in standard form and compare that way. 1.2 times 10 to the 4th means 1, 2, we're going to move it over 4 times. So 1, 2, 3, 4. So that is 12,000. Okay. 2.1, move that 3 places, would be 1, 2, 3. All right, 2,100. So here, 12,000 is bigger. So how we write that as a final answer if this was on a test is take the beginning question, rewrite it, and put the right comparison symbol there. Okay. And now you have practice, so go ahead and go for it. There's a little blurb in the book about scientific calculators. Now, different calculators display this differently, okay? Some will show it as scientific notation. And so take your calculator, any calculator you have at home, and multiply 1 million by 1 million. And so to do that, you would do 1 with 6 zeros. Multiply it by 1 times 6 zeros and see what you get. Some calculators will come up with something like 1 times 10 to the 12th. Some might say 1e 12. That means 1 with an exponent of 12. That means 10 to the 12th. And some will say 1 to the 12th. So it's really a fun experiment. Go ahead and take your calculator and multiply 1 million times 1 million and see how your calculator answers that, okay? Because it's going to be 1 with 12 zeros. And how are they going to display that? Go ahead and check that on your own. And then go ahead and do the practice and come back and check your answers if you get stuck. If they don't match the solution manual, come back and get some help. And you may begin. All right, so write each number in scientific notation. Again, we're going to take that. 1 is in the ones spot, and everybody else is in decimal world. So it's 1.5, and I've got 1, 2, 3, 4, 5, 6, 7 in the decimal. Okay? That decimal moves 7 places. This one is just going to be 4.0, and it moved... let's see, did I do that right? 1, 2, 3, 4, 5, 6, 7. Yeah, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times 10 to the 11th. Okay, this one would be 5.09 times 10 to the 1, 2, 3, 4, 5, 6. Okay. 250 billion. Let's think of it this way. 250 billion would be that, right? So that is 2.5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Write each number in standard form. A little bit easier than I think above. So 3.4 times 10 to the 6. So that's 1, 2, 3, 4, 5, 6. All right, 5 times 10 to the 8th would be 1, 2, 3, 4, 5, 6, 7, 8. And then I come back and put my commas in. 1 times 10 to the 5th would be 1, and then 1, 2, 3, 4, 5. All right, those are fun. Now we're going to compare these one time. So we're going to put them in standard form and then compare. That'd be the best way. So what we have is 1, 2, 3, 4, 5. So we got 150,000. And 1, 2, 3, 4, 5, 6. 150,000. So what we're going to say there then, no, I did that wrong. 1, 2, 3, 4, 5. Sorry about that. You were about to call me and get credit, but look, I caught it. So it's 100 or 1,500,000. So this one is bigger. So we're gonna, so it's like that, right? So the final answer would be 1.5 times 10 to the 5th is less than 1.5 times 10 to the 6th. And there we go. There's the final answer. All right, 1 million. Get used to millions being 6 zeros. And, oh, 1 with 6 zeros. 1, 2, 3, 4, 5, 6. So they are actually equal values. Isn't that exciting? All right, so I think we got through that in about 11 minutes, plus the warm-up. So you're welcome for that. And I hope this was a fun one. And I might have a mistake in there because it is late and I apologize. So call me, text me, email me if there was a problem.